Okay, so now we're going to look at this factor affecting the rate of enzymatic reaction. So basically means that, okay, we do have enzyme, we do have the substrate, we let them actually, carry out the catalysis process and reactions. And at the end, we're going to look at this, how fast the reactions can take place. But again, this rate of reaction also will be affected by some other factors. So what are the factors? We're going to look at it today. We're going to look at the concentrations of the enzyme or enzyme concentrations. Second, we look at the substrate concentration. And next, we look at the temperature as well as the pH. Okay, so basically, when you talk about these, these two, we are referring to the number. And we're going to talk about limiting factor. Okay, I will show you guys what this means, limiting factors. And these two, we are talking about the bonds. Okay, because of the breakage of the bond. Like for example, high temperature, because of the high kinetic energy, high heat energy, break the hydrogen bonds. And pH change actually break the ionic bond as well as the hydrogen bonds. Okay, so we're going to look at the detail about these four factors now. Okay, so first, let us look at the concentration of enzymes. Okay, so as usually, generally, when you increase the enzyme concentration, we're going to increase the rates of reactions. That is confirmed, correct or not? Okay, provided that substrate is in excess. So it means that we have more substrate compared to the enzymes. Therefore, you can see that the reaction rate actually directly proportional to the enzyme concentration. That's because more enzyme present, we're going to have more active sites, okay, will be available for the substrate. Okay, so let me show you guys one analogy in this case. So in this analogy, I'm going to talk about the enzyme. Okay, enzyme actually equates as my stuff. Okay, as my stuff, right? Enzyme. Second, I put a substrate as my customer or my work. Okay, so at one particular times, okay, the staff, okay, let's say 1 hour time. In 1 hour time, one staff can finish only one work. This is my rate. Are you clear? So look at this, what happened. If this is my company, okay, this is my company. So I have my staff number. I have my work number. And then how fast my worker can finish the work, I call it as the rate. Okay, so let's say, for example, I try to find the work for my staff to do. I have 10 works total. But now I only have one worker. If I have one worker, so at every hour, only one work can be done. Because I only have one staff only. So it means that no matter how this staff do, the work will have 10 of them. So my staff have to take 1 hour, only can do one work. So definitely one work done. Are you clear? Per staff. Now try to imagine that I say, oh, one staff not enough. My work so much of work here. So I hire more staff. So I increase to 5 staff. Work still remain the same. Then you can see that what is the rate? The rate will increase now. Can you see that? To 5 because everyone have one work to do. So in 1 hour, I have 5 staff to complete 5 works for me. So therefore, the rate increased already. Can you see that? Are you clear? But I see that not enough. I increase my staff number to 10. My work still continued with 10. I didn't increase my work now. So my staff had 10 staff. So it means that at this moment, you can see that 10 staff, each of them can finish one work in 1 hour. So therefore, 10 staff, I'm going to have 10 works done per hour. So therefore, you can see that the rate increased. So it means that I increase the enzyme concentration, definitely going to increase my rate of reactions. Correct or not? So if I plot the graph now, okay, so this is the enzyme concentrations. And then this part is my rate of reactions, the initial rate of reactions. And you can see that the graph now increase. Okay, continue increase. So, but now I'm thinking that, hey, if I continue to hire my staff, okay, increase to 12, but my work still 10. Can you see that? My work still remain 10. So what does this mean? I have 12 workers, but 10 works only. So means that my rate also will stay at 10. Why? Because I have no more work for them to do. So means that beyond this point, you can see that I have more stuff than the work. If I have more stuff than the work, so means that now I say that you have the limiting factor here, correct or not? The work is the one that limits the process. Initially, if you look at this part, okay, generally, okay, put this way first. Generally, you can see that I have more substrates than enzyme. So enzyme will act as limiting factor. Why limiting factor? Because if I increase the number of the enzyme, then I have more work done per hour or per unit times, correct or not? But when you come to this part, so I increase, let's say increase of 15, useless, because my work will limit the process. Can you see that? So in this case, you can see that my enzymes actually more than the substrate. So it means that now substrate act as the limiting factor. So in our syllabus, we need to know how to explain this limiting factor. So no matter how I increase my enzyme concentration, it won't going to change. So this one will remain constant. So we say that level off now. Okay, so you can see that now my graph will continue to increase until level off. Are you clear? So when it level off, what we're going to do here is at the level of regions here, I will draw a line to break my graph into two parts to explain. Okay, so if I put it here, K concentration. So below K concentration, what will happen? Below K concentration. So right now here, below K concentrations, this part, enzyme concentration actually act as limiting factor. Okay, enzymes act as limiting factor. So why? Because enzyme actually less than substrate. Correct or not? Not enough enzyme to do the work for me. Are you clear? So enzyme less than substrate. So what happened here means that at any particular time, all enzyme active site occupied by the substrate. Are you clear? All enzyme active site. I have done already. I can't do anything. I have two hands only. You give me so many work, I can't do. Continue. That is the maximum I can do. Are you clear? So this part. Okay. So now, second part here. Above K concentration, now we do know that enzyme concentrations no longer act as limiting factor. Because why? Now I have more enzyme compared to the substrate now. Because I keep on increasing, right? I keep on increasing the enzyme concentration. So it means that enzyme more than substrate. So what actually happened here? So some enzyme active site are unoccupied. Because why? I have more enzymes, but substrate. So it means that in this case, substrate concentration act as a limiting factor. Are you clear? Okay, so some enzyme active site are unoccupied, so that's why substrate concentration now act as a limiting factor. Okay, so you can copy down for this. How you explain the graph. So be careful, is the enzyme versus initial rate. Sorry, is the initial rate of reactions versus enzyme concentrations. Are you clear? Okay, done for this part. So when the substrate concentration acts as limiting factor, means that we don't have enough work. Okay, we don't have enough work for my worker, then the rate of reaction then stagnant there. right? Constant. We say reach the plateau. Now, can you see that reach a plateau? So at a particular time, all substrate molecules have been fitted into the active site of the enzyme. So it means that some of the enzyme active sites now remain unoccupied. So it means that my worker, for example, I have 10 works, but I hire 15, 5 of them do nothing. Sit there and watching. Are you clear? So they do nothing because no work for them to do. So they just sit there and then do nothing. So you can see that how we can generate this graph. So it means that I have the different reactions here. For example, I have times, okay, I have reactions. For example, the first set of reactions, I use 1/4 of this enzymes. So I plot it. So 2/4 of the enzyme, continue, 3/4, and so on, 4/4, until a moment you can see that they level off. So when it level off already, then we do know that now, if I put it here, guys, so this part, I know enzyme not enough. So enzyme concentration act as limiting factor. Okay, so this part, enzyme concentration, no longer act as limiting factor now. Because I have a lot, right? You can see that I keep on increasing the concentration. I keep on increasing until they more than enzyme, actually more than the substrate. So means that at the particular time, some of the active site of the enzyme molecule remain unoccupied. Okay, clear? So next, we look at the opposite case now, the concentration of the substrates. So again, when I increase the substrate concentration, we increase the rate of reactions, again, provided that enzyme must in excess. So in this case, I have to make sure that I have sufficient enzyme. Are you clear? So enzyme must be more than my substrate. Okay, so at low substrate concentration, the rate of enzyme reaction increases with increasing substrate concentration. When the enzyme concentration act as limiting factor, means that we don't have sufficient enzyme in this case, the rate of reaction now level off again, because all active site enzyme molecule are fully occupied, means that all enzyme work already. So we don't have any extra enzyme there to help us. So therefore, we can see that my enzyme concentration is working at the maximum possible rate. We term it as the Vmax. V stands for velocity, means that it's the maximum rates that we can achieve with that particular concentration when substrate concentration no longer act as limiting factor. Unless we change the concentration of enzyme, if no Vmax is achieved. Are you clear? Okay, so let me show you the example now. So you look at this now. If let's say I have 10 stuff, but I only have 1 work. So you can see that now the rate will be lower because at this moment, I only have 1 staff doing work, the 9 of them are looking at this one. Okay, do work, okay? So the rate will be 1. But if let's say the staff still remain the same, I don't change the staff number, but I try to find more work. So I increase the work to 5. So the rate also will equal to 5 because why? Limiting factor is still the substrate concentration, the work here, not enough work to give to my staff. So some of my staff actually remain unoccupied with the work. Okay, so I continue to increase my work until 10. Then I increase the rate to 10. Why? Because at this moment, you can see that all of them will have the work already. But the question here is, if I continue with 10 staff, but I increase the work to 15 works, but my staff already work at the maximum rate, 10 of them, this is the number of work I can have, 10. I cannot further increase anymore. Because why? I don't have sufficient manpower. So if I increase to 20, no choice, my work still, the rate still equal to 10. And you see that it's level off. So if you plot the graph now, you can see that initially increase and then level off. So this one is a substrate concentration. This is the V0. Okay, means the initial rate of reactions. So again, if I break into 2 parts now, here K concentration, then what we're going to explain here is in this part. So who acts as a limiting factor? Substrate concentration act as a limiting factor. Why? Because I have substrates less than enzyme. Are you clear? So it means that some of my worker actually they are doing nothing. So basically, you can see that some active sites of the enzyme are unoccupied. So means that my enzyme haven't worked at the maximum rate yet. Are you clear? But this part, then substrate concentrations no longer, because I increase, can you see that I increase the concentrations, right? Substrate concentration increase. So substrate concentration no longer act as limiting factor. Why? Because I have substrate more than enzyme. So at this moment, I know that all active sites are occupied. All of them occupied already. So means that my enzyme work at maximum rate now. Okay, the highest already, because I already occupied all the active sites already. What can I do? I can't do anything unless I add more. Okay, unless I add more enzymes. Are you clear? So therefore, we know that in this moment, enzyme concentration act as limiting factor. Are you clear? So because the enzyme concentration act as limiting factor, therefore, I mean my substrate actually more than my enzymes. So if from this graph, I extrapolate from the plateau here to the vertical axis, this part, this value means V max. Are you clear? V stands for velocity. So it means that it is a maximum rate that I can achieve with these concentrations of the enzyme when substrate concentration no longer act as limiting factor. So what is Vmax? So Vmax basically is the maximum rate when substrate concentration no longer act as limiting factor. Are you clear? Understand, guys, so far? Can, so this is Vmax. So for the next two parts of the topics, we're going to look at the enzyme kinetic. We're going to look at Vmax again. So understand the concept of Vmax first. So what's mean Vmax? Vmax is the maximum rate when substrate concentration no longer act as limiting factor. Okay, so means that for that particular concentration, because whenever I change the concentration, if I change the concentrations, then I will be able to change the Vmax. For example, we look at now. If I think that, okay, I still have 20 works. I say stop not enough, so I increase to 11. So can you see that now? I work at 11 now. If I increase to 12, my rate increase. Why increase? Because I change my staff number. So as long as you don't change your staff number, then with this number of staff, this will be the maximum rates that I can have. I won't be able to get any further increase unless I change my enzyme concentration. So with that particular enzyme concentration, therefore, that is the maximum already. I won't be able to increase anymore. So that maximum rate is termed as Vmax. Okay, So if you look at this graph here, now you can see that, okay, so different concentration of substrate will give us the final volume differently. But if I check the initial rate of reactions, then you can see that it go up to a particular moment, then plateau. Okay, so at these plateau regions, then I can drag a line, then it will give us the Vmax. What is the meaning of Vmax? Vmax basically means that's the maximum rate of reactions, okay? Maximum rate of reactions, okay, when the substrate concentration no longer act as limiting factor. We have to make sure that all enzyme active site already occupied with the substrate. So therefore, my enzyme work at the maximum rate, okay? So the next part, let us look at the temperature. So how the temperature actually affect the rate of reaction. So first of all, when you have the low temperature, so low temperature indicates that the kinetic energy is low, so the rate of reaction is very low due to the slow movement. Because kinetic energy is low, so therefore low movement. Okay, so if a low movement, what is the frequency of effective collision? frequency of effective collisions definitely will very, very low because it takes longer period of time to collide to each other. So in this case, try to imagine that if I put all of you guys in one room and then I blindfold all of you and all of you walk slowly. So what is the chance for you to hit on each other? And we have to make sure that you hit it in the correct orientation somewhere, right? So your enzyme and the substrates actually collide at the different area, then the rate will be very, very low. So for the effective collisions, okay? But when you increase the temperature, if they say increased temperature means that substrate molecule enzyme now have higher kinetic energy. For example, try to imagine that now. So in this room, okay, you are blindfold, don't know anything, you randomly move. Then I say that, hey, I throw two snakes or few snakes inside this room, okay? So please run. So now you guys were worried that you guys were bitten by the snake, then you guys start to run. I mean, even faster. I mean, when you run faster, generally means that you're going to bump to each other, bang each other, okay, or hit each other, okay, in a higher frequency. Correct or not? So because we increase the number of effective collisions, okay, so to form this enzyme substrate complex, therefore more products can be formed per unit of times. But this is only true when we increase the temperature all the way to optimum temperature. So when at an optimum temperature, the temperature at which the enzyme catalyzes the reactions at a maximum rate. The best already, you wouldn't get any higher. So generally for human enzyme will be normally optimum temperature will be around 40 or 37 to 40 degrees Celsius. Okay, so I have one terms that I actually want to introduce to you guys. It's called Q10 Temperature Coefficient. So this Q10 value or Q10 coefficient is a measure of the rate of reaction. Okay, when every increase of 10 degrees Celsius, okay, we calculate this Q10 coefficient. So basically, increase in the surrounding temperature will increase 10 degrees Celsius in an enzymatic reactions. It will result in doubling up of the reaction rate. And this is very important, okay? Even though Q10 effect is not in our syllabus, but we do need to know about this Q10 effects. So what's the Q10 effects mean? So Q10 effects, Q10, how to calculate Q10? Q10 equal to rate of reactions at theta plus 10 degrees Celsius divided by the rate of reactions at theta degrees Celsius. Okay, let me copy. Okay, now what's this mean? Let's say, give you guys a table. Let's say this is the temperature in degrees Celsius. Then this is the rate of reactions in arbitrary units. Okay, so let's say at 10 degrees Celsius, I have 5. Okay, the rate of reaction is 5. Then I increase to 20 degrees Celsius, then I get 10. If I increase to 30 degrees Celsius, you're going to see it double up. So means that if I take the temperature equal to 10 degrees Celsius, so means that here 10 plus 10 equal to 20. So 20, if let's say theta equal to 10, so therefore you can see that if a theta equal to 10, theta plus 10 equal to 20. So 20, you see that the rate equal to 10 units, and then divided by the rate of reactions at theta equal to 10, so 5. So equal to 2. So this is very, very important. If your Q10 value of reaction is equal to 2 or almost equal to 2 or around value 2, then means that this reaction actually depends on the enzyme, because only enzyme can help us to achieve this Q10 value of 2. Are you clear? But this is only true before we reach the optimum temperature. So when you draw a graph later, you can see that there must be exponentially increase, because from 0, you get 2. 2 times 2, you get 4. 4 times 4, you get 16. 4 times 2, you got 8. 8 times 2, you got 16 and 32. So it keep on increasing in the exponential rate. Can you see that? And when you reach a maximum rate, means at the optimum temperature, then you can see that they drop very, very steeply. The rate of reaction, can you see, decrease very, very steeply. Are you clear? And this is very, very important, guys, because of the denaturation. Why it drops so fast? Basically because of the denaturation. So how you explain denaturations? As we know that above optimal temperature, heat energy too high. So this heat energy actually caused the breakdowns of the hydrogen bonds, okay, between the R groups of the amino acid. So enzyme molecule now lose their precise three-dimensional shape. Highlight the word precise. Now this is very important, guys. A lot of students say they lose their three-dimensional shape. Impossible, yeah. Every single matter in this world, they will have three-dimensional shape. So no matter how enzyme won't lose the three-dimensional shape, it won't be from three-dimensional become two-dimensional, become one-dimensional. Cannot, impossible. Okay, because the loss of the shape in this case, okay, is just because of precise. So it means that it becomes different three-dimensional shape, which cannot carry out the functions of the enzymes already. So the shape of the active site now of the some enzyme no longer complementary to the shape of substrates. Therefore, less ES complex are formed, and the denaturations now is irreversible. Okay, now this is in general. Why is it in general? We have to look at where we are referring to. If you're referring to this area, let's say I put it as A and here B. Then you have to understand at A, the graph at the A part here, mean, okay, not all enzyme denature, some denature. Why some? Because you can see still have the rate. And this rate actually is higher from this. Huh? You can see that. If you compare, it's still higher compared to the low temperature. So it means that enzymatic reactions still take place. But if you compare to the optimum temperature, definitely lower. And this is because some of the enzyme now, they lose their precise three-dimensional shape. Therefore, some of this enzyme, the active site now, no longer complementary to the shape of the substrate. Are you clear? Okay, but you look at the B. When you talk about the B, then you can see that the rate actually equal to 0. Can you see that? At B, the rate of its reaction equal to 0. So it means that O enzyme denature. So therefore, the rate equal to 0. You can't catalyze the reaction at all because all of them now cannot function. It's too high the temperature until the denaturation take place. And this denaturation is irreversible. So what is irreversible? You cannot reverse it. Okay? So one of the good examples, if you look at this, when you fry the egg white, because egg white actually full with the albumin, correct or not? Okay, the protein. So denaturation, can you see that? It turned from the liquid stage into the solid form. Are you clear? But if you leave your egg after you cook it and leave it for 5 minutes, it cool down. Will you form back liquid stage? No. Then what for? You cook it. You cook it, it becomes solid, and then you actually let it cool down. When it cool down, it becomes liquid again. It's not happens. Okay, won't happen in our proteins. So therefore, we say that the denaturation is irreversible. Okay, clear? Any question? Now, students commonly make some of the mistake here that by saying, oh, temperature break the hydrogen bonds. It's not true. Hydrogen bond are broken down by heat energy. Okay, because of the heat energy, then you can see the vibrations of the particle between two R group is so strong until they can't form a stable hydrogen bonds, and then they break these hydrogen bonds. Clear? So the last one, we look at the pH. So the most favorable pH at the point where enzyme is most active means the highest rate is known as the optimum pH, or different enzyme will work at different, okay, pH. As I say that, okay, can you see that? When you look at this, when the pepsin, we have the 2, means a very acidic, and lipase normally 8 to 9. So in the alkaline conditions. So if you have a deviation from this narrow pH, it will result in the excess H plus or OH minus. So it depends. If let's say pH drop, very acidic, so means that the concentrations of the H plus increase. Okay, or the pH is high, mean alkaline, means the concentration of OH minus increase. So no matter how they're going to break ionic bond. Now be careful, guys. If question asks you one bond, which bond? Which bond when the deviation of pH can cause or change of pH can break ionic bond. If the question asks for more, then you put in a second one, hydrogen bond. Are you clear? So it means that deviation of pH firstly will break the ionic bonds and then continue with the hydrogen bonds. And always remember, it's a deviation of the pH, not pH. pH cannot break the bonds, right? Okay, only the deviation of pH. So the alterations of the interaction of the acidic and basic R group, in this case, resulting in the breakage of the ionic bonds. Again, the precise three-dimensional shape of enzyme is altered, is changed. So therefore, enzyme is denatured. Okay, so the shape of active site now no longer complementary to the shape of substrates. So therefore, the enzyme actually didn't work at the maximum rate or even can't functions at all. Okay, so with this, I have done for the factor affecting the rate of reactions.